Okay, in exercise 6.2, question 1, the exercise called functions and relations, and that's what we're doing here. We're looking to see whether we can identify things as being functions and relations. In question 1, though, we're identifying things. So we're given some information, and then we're saying, is it a function or is it a relation? Now, anything that has x or y values is a relation. A function is a special kind of relation. So that's why I've drawn it here in this Venn diagram. So the whole thing are relations, and functions are a part of it. So let's have a look at some stuff. We're also looking at domains and ranges. Now, domains are x values, putting that in brackets, and then ranges are, what do you think? Well, they're y values. So let's say you're given this. We've got this set here, 1 and 2, 2 and 3, 3 and 4, 1 and 4. So these are just dots on a Cartesian plane. That's our relation there. So we're determining whether that is a function or not here in question 1. So what we want to do, we want to look for our x values. If any of them are repeated, it is not a function. So looking at this, we've got 1 and 2, 2 and 3, 3 and 4, 1 and 4. Well, we've got a 1 here, we've got a 1 here, so therefore it is not a function. It is just a relation. Alright, now, so the domain is our x values. So this relation goes from 1 all the way out to 3, and it includes both of those numbers. Likewise, the range, the y values, 2, 3, 4, and 4. So it goes from 2 and it goes out to 4. So they're included as well. So that's the way that's where we go through that. If this here was a negative 1, well then in that case it would be a function, and its domain would be negative 1 to 3, because negative 1 is the smallest number. So it doesn't matter what order these are written in. Whatever we have on our left of our domain or our range is always the smallest number. Alright, let's have a look at this thing here. So we've got a parabola on its side. It's going like this with some arrows and an intersection there of 4 and 0, or a point there of 4 and 0 rather. So what we're doing is we're looking at this. Now, once again, we're looking for repeated x values. So we look at this, say we've got our x value here of 0, here at x equals 0. We've got a y value here, it's negative something, and then we've got a y value here of positive something. So as a result of that, we've got 2 x values for a different y value, for one y value. As a result of that, this here is not a function. We can also check these. If we get them graphically, we can draw lines. We do what we call the vertical line test. Now this vertical line test, the vertical line, if it cuts through more than once, it's not a function. So now with this, we've also got to specify our domain. So our x values. These arrows indicate that our graph goes on forever. The arrows are heading towards what value? Negative infinity. Can it ever include negative infinity? No, so we need a rounded bracket. Now, on the right, it reaches a value of 4. So that's what we write down here. That's our biggest value, 4. It includes the 4 because it's actually touching 4. So that's the way we draw that there. Now, our range. Our arrows, if we were to keep going this forever, we'd find that our graph just got bigger and bigger and further apart. So as a result, our range is all real numbers. The last graph over here, on the right, a little bit different. It's a parabola, once again, and we can see that it stops at 4 and negative 4 and 5. It's got a turning point negative 2 and negative 4, and let's put in another value here of say 1 and 3. Forgot to write that in, doesn't matter. Okay, so with this one, firstly we want to do is want to find out if it's a function. We've got a graph, we'll draw some vertical lines. Yep, it's a function. So function, give it a big fat tick, so we know that it's a function. Now we're after the domain. So we're looking for the x values that the function takes. So if we have a look, There's an endpoint here at -4. There's an endpoint at 1. It doesn't exist less than -4. It doesn't exist more than 1. So as a result of that, its domain is -4. Let's draw that a bit clearer. -4 out to 1. And closed circle, so it's inclusive. The range. Now, the range. Sometimes, if you are given this thing as an equation, people make a mistake, and I'll say the range goes from 3 to 5, because I'll look at the endpoints, and they say, or they may look at these two endpoints, they'll substitute values in for x and get y values of 5 and 3, and say the range goes from 3 to 5. That is not correct. Always graph it. Here you've been given a graph. Now your range is your set of y values. If you look at it, our graph goes from -4, because that's our minimum value, -4 all the way up to 5. So that's our range. So our range is -4 inclusive, because it actually touches that point, and it goes out to 5. So there we go. That's what we're doing here. So functions, repeated x values. If we're given a graph, we draw a vertical line. If it cuts through more than once, it's not a function. If it cuts through once, it is a function. Then we're after the mains, which is a set of x values. They are the x values which a function or a relation takes. That's their x values. Our range is our y values. They're our y values. So that is how far. So we're looking at our set of y values. Be wary of your circles, your endpoints. If they're closed, make sure that your domains and ranges are labelled appropriately.
You need a secret sound in your videos.
Why? To make it interesting?
Yeah. Put a secret sound, something from home, and if they guess the secret sound, give them a chocolate bar.
Oh, yeah.
You know, a little mini chocolate bar.